All right, Algebra 13.5, surface areas of prisms and cylinders. For this one, I have gone back to taking pictures of your textbook and uploading them because there's just a lot of pictures and diagrams and things happening in this, and it was going to be impossible for me to keep up with kind of drawing everything in. And it would just be too many opportunities for you guys to laugh at my artwork. So here we go. What is a three-dimensional figure? It is a shape whose points do not all lie in the same plane. Here we have three-dimensional figures, okay? So what I want you to be thinking about as we move through this section is, what do these figures look like in real life? Okay, so we could say this is an Amazon box, okay? This is a triangular block of cheese, okay? This could be a soda can, okay? Now, let's talk about some definitions of some definitions that are applicable to 3D figures, all right? So first of all, a polyhedron. And a polyhedron is a closed three-dimensional figure with flat surfaces that are polygons. The first two figures above are what we call polyhedra. That's the plural form. So here, this is a polyhedron, and so is this one right here. The reason that our soda can figure is not is because it does not have flat faces, and we will come back to that, okay? What is a face? A face is any of the polygons that makes up a polyhedron, okay? So all the shapes, basically, that make up the polyhedron, all right? An edge is a line of intersection of two faces of a polyhedron. A vertex is any point where three or more faces of a polyhedron intersect, plural form vertices, okay? A prism is a polyhedron with two congruent parallel faces, so two parallel faces that are the same size, okay? Bases are congruent parallel faces of a prism, and lateral faces are all the faces of a prism or a pyramid except for the bases, okay? So up here, polyhedron, here, polyhedron, soda can, not a polyhedron, okay? A face, this is a face of this polyhedron. This is a face of this polyhedron right here, okay? An edge, a line of intersection of two faces of a polyhedron. Here's an edge, and here's an edge, okay? A vertex, any point where three or more faces intersect. Here's a vertex, here's a vertex, all right? Okay, to the right of all these definitions, we have a couple prisms, okay? If the lateral edges of a prism are perpendicular to the plane of the base, the prism is called a right prism. And all of its lateral faces are rectangles. So here is a right prism. We have the bases. I'm just going to outline these guys. Okay, there's the bases. Okay, bases are congruent parallel faces of a prism. So we've got a base here and a base here. They're parallel to one another. They're going to be the same size. Okay. And the lateral edges, okay, the lateral edges of the prism are perpendicular to the plane of the base. So like here is a lateral edge perpendicular to the plane of the base. This is a right prism. All its lateral faces are rectangles. So here I'm just outlining one of the rectangles that makes this up, all right? If the lateral edges of a prism are not perpendicular to the plane of a base, the prism is called an oblique prism, and its lateral faces are parallelograms that are not rectangular. So see how this guy looks slanted, all right? This guy looks slanted because the lateral edges are not perpendicular to the plane of the base, okay? They do not make right angles with the base. Prisms are named for the shape of their bases. Since a rectangular prism has 3 pairs of parallel faces, any parallel pair can be considered the bases of a rectangular prism. This is not true of a triangular prism, since it has only 1 pair of parallel faces, or of any prism whose base has more than 4 sides. So the first one we have here is a rectangular prism, and it has 2 parallel congruent rectangular bases, okay? So we could have bases, whoops, I guess I don't have to dash those guys. Okay, that is a set of bases, okay, in that one. This, or these two, is also a pair of parallel congruent faces, so those could also be considered bases of this rectangular prism. And lastly, which ones have I not outlined yet? This one. This one, and I like that blue and that pink together. And the ones in the back, okay? The front and the back faces could also be considered bases of this rectangular prism, okay? Moving right along to a triangular prism. And in this case, we only have 2 parallel congruent bases, okay? A triangular prism is only going to have 1 pair of parallel faces, and there they are right there. That's why they're called the bases, okay? And then we have a cube over here, which is a special type of rectangular prism that has 6 square congruent faces. A rectangular prism has 6 faces, the 2 bases and 4 lateral faces. It has 12 edges, 4 on each base and 4 connecting the lateral faces. It has 8 vertices, 4 on each base. The lateral surface area of a prism is the sum of the areas of its lateral faces. Okay, lateral surface area, capital L, sum of the area of its lateral faces. The surface area, capital S, of a prism is the sum of the areas of all of its surfaces. If you unfold a rectangular prism, think about when we get the Operation Christmas Child boxes, okay, and they're just flat, okay, or think about maybe you guys, your family has been shopping on Amazon during quarantine, and you've got some boxes in the garage, okay, or a cereal box, okay. Grab a rectangular box that you don't need anymore and flatten it out, and you can see a little bit clearer what we're talking about here. If you unfold a rectangular prism, you form what's called a net. And when you do that, you see the 6 surfaces of that rectangular prism as separate rectangles. To find the surface area of the prism, you find the area of all of those rectangles and add them all up, all right? So, area of the bottom base times height, 9 times 4, 36 inches. So what are we talking about here? Bottom base. We're talking about this one right down here. This is the bottom base, all right? Then we have the area of the right side, okay, of the right side. 4 times 3 is 12 inches, right? So the right side, here's the right side, all right? Then we have the area of the front. Base times height, 9 times 3 is 27 inches. So that, and I'm going to just kind of shade this guy back here and then sort of overlap so you can see this kind of comes down. This is the front, okay? Now, capital S, big S, is the area of both of the bases, the area of both of the sides, and the area of the front and the back. So our pink, okay, our purple, both the sides, and our blue, the area of both the bases. Now, there's 2 bases, so it's 2 times 36. There are 2 sides, 2 times 12, and of course, there are 2 front and back. Okay, there's the front and the back. So 2 times 27. So the total surface area of this whole rectangular prism is 150 inches squared. Now, here, this is what we're talking about when we're talking about the net. Okay, this is the net. This is taking this prism, unfolding it, and getting that. Okay, so we have the area of the front, okay, 9 times 3. So here is the front, and here is the back, all right? The 2 sides are here and here, and the bottom and top bases are here and here, okay? Examining the net, you will notice that when a prism unfolds, it forms a large rectangle with 2 flaps that form the 2 bases of the prism. The area of the long rectangle comprises the 4 lateral surfaces of the prism, and therefore the lateral surface area, capital L, of the prism. The rectangle's dimensions are the perimeter of the base and the height of the prism, h. So capital L is the lowercase p perimeter of the base, which is 26, okay, times the height of the prism, which is 3. So where did that come from again? I'm going to use a different color. Use this green. So what we're talking about, the lateral surface area is the long rectangle, lateral surface area, big L, perimeter of the base, and the height of the prism. What we're talking about is this long rectangle when you unfold right here, okay? Where is this 26 from? The perimeter of this long rectangle is 4 plus 9, that's 9 right there, plus 4, another 4 right here, plus another 9. Okay, 4 plus 9 plus 4 plus 9 is 26. Okay, and the height is this right here, 3 inches. Okay, so capital L is the perimeter of the base, lowercase p times the height of the prism. The total surface area, capital S, can be determined by adding the lateral surface area, capital L, and the combined area of the 2 bases. 2 times big B, where we're saying big B, okay, is the area of the 2 bases. Where are the bases? Let me change colors again. Sorry. Big B right here. Where is big B? Well, it says 9 times 4. Our bases are here and here in the lateral surface area formula. Okay, so B is lowercase b times h of the bases. So what we're going to do here is we're going to take the 2 times the area of the bases, because there's 2 of them, okay, 2 times the area of the bases, plus L, okay, which is our lateral surface area, which was 78 inches. So we have 78 right here, 78 inches squared, plus 72, which is 9 times 4, which is 36. So the area of one of those bases times 2, because there's 2 bases, 72. Guess what? What did we end up with? We ended up with, dun 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 dun, 150 inches squared. What did we end up with our other surface area formula? 150 inches squared. It's the same, okay? So, two formulas. Lateral surface area of a prism. Lateral surface area of a prism, again, is just our green, okay? It's the long rectangle area, all right, that does not include the area of the bases. So it is the area of the four faces that are not the bases of a rectangular prism, okay? So lateral surface area of a prism, capital L, right here, is equal to lowercase p times big H. Lateral surface area of a prism, big L, is equal to the product of the perimeter of the base, lowercase p, and the height of the prism, big H. Formula for the total surface area of a prism, okay? Total surface area is L, okay? The lateral surface area plus 2 times the area of the base, okay? So, or you could just say lateral surface area plus the area of the two bases. All right, so let's look at that in example number 1. Find the lateral surface area and surface area of the prism, okay? This is a triangular prism. We're going to go ahead and find the lateral surface area and the surface area of the prism. Big L is equal to little p times big H. So we want to determine little p and big H. First of all, what's the height of this prism? There's the height, 8 centimeters, okay? H is equal to 8 little p, okay? What is little p again? It's the perimeter of the base. What is the perimeter of the base? 3 plus 4 plus 5. I know that's 5 because this up here is 5. 3 plus 4 plus 5 is equal to 12, okay? So now I can figure out my lateral surface area. Little p, 12 times big H, 8 is equal to 72. Why did I say 72? 96. I'm not going to erase that. 96, what units are we talking about? Centimeters squared. Surface area is area, so it's squared, all right? Now, in order to figure out big S, that is equal to big L plus 2B, okay? So S is going to be equal to 96 plus the area, or excuse me, B is the area of the triangular base, right? Well, what is the area of the triangular base? Big B, in this case, is going to be the area of the triangle, okay? 1/2 base times height. So take a look at the base triangles, okay? We have 3, 4, and 5, all right? 1/2 base times height of this triangle. The 5 is across from that 90-degree angle. So base and height of the triangle. So big B in this case is 1/2 base times height, because that's the area of a triangle. So big B in this case is 1/2 times 3 times 4, which is equal to 6, okay? So back over to our formula where big S is equal to lateral surface area plus 2 times the area of the base. So 96 plus 2 times the area of the base is 12. 96 plus 2 times 12, 2 times 12 is 24. 96 plus, why did I put 12? This is why you shouldn't do math, kids, at 11 o'clock at night. Sorry. B, 96 plus 2 times 6, not 2 times 12. I was going a step ahead. 96 plus 2 times 6 is 12. So 96 plus 12 is 108 centimeters squared. And there is the answer. All right. Skill check number 1, find the surface area of the following prisms. Drawing a net may be helpful. Here is my caveat. If drawing 3D figures, drawing out these nets, if that seems really stressful to you, don't do it, okay? Don't draw the nets. If you think it would help you, go for it, okay? Absolutely go for it. But if you think it's going to stress you out, don't do it, okay? All right, so skill check number 1. Find the surface area of the following prisms. Okay, rectangular prism, 5 by 12 by 8, all right? I think it's going to be easier if I just skip over to another page. So 5 by 12 by 8, I believe those were all centimeters. Okay, 5 by 12 by 8. So big S is equal to big L times 2B. Big L is equal to little p times big H. Okay, so the first thing we need to determine is what is the height. Here is the height. Okay, H is equal to 5 centimeters. P is the perimeter of the base. That is going to be 12 plus 12 plus 8 plus 8. Okay, 12 plus 12 is 24. 8 plus 8 is 16. 40 centimeters. Okay, so big L is equal to 5 times 40, which is 200 centimeters squared. Now, to figure out my big S, that is equal to 200 plus 2 times big B. What is big B? Big B is the area of my base. The area of the base is 12 times 8. 12 times 8 is 96 centimeters squared. So now I'm going to plug that in for big B. S is equal to 200 plus 2 times 96. S is equal to 200 plus 2 times 96 is 192. S is equal to 392 centimeters squared. That's how we work through number 1. I'm going to skip number 2. I'm going to let you work on that one on your own. 2, you should come up with 181.5 feet squared. Number 3, inbox skill check number 1, a triangular prism with dimensions of 5 feet by 12 feet by 13 feet, okay, or 5 feet by 12 feet by 13 foot bases, and a height of 10 feet. So again, big S is equal to big L plus 2 times big B. L is equal to little p times H. So the perimeter of my bases, little p, 5 plus 12 plus 13, that's equal to 30. The height is 10, so big L is 30 times 10, which is 300, okay? What about big B, the area of the base? Okay, area of the base. Remember, in a triangle, the longest side is the hypotenuse. Longest side is the hypotenuse, which means here's the base and the height of our triangle, okay? So the area of that base is going to be the area formula for a triangle. So 1/2 times 5 times 12. 5 times 12 is 60. 1/2 of that is 30. So now I have everything I need. I have L is equal to 300. Big B is equal to 30. So big S, I'll do it later. Big S is equal to 300 plus 2 times 30. Big S is equal to 300 plus 60. Big S is equal to 360. And my units are feet squared. So that is how we arrive at the solution for number 3. Okay, now I'm going back and we're going to start talking about circular cylinders. I said we'd come back to those. Those are our soda cans, okay? A circular cylinder is a 3-dimensional figure with 2 parallel bases that are congruent circles. The curved surface is the lateral surface. If you unfold a cylinder to form a net, the lateral surface will form a rectangle. The base of the rectangle is the circumference of the base of the cylinder, and the height of the rectangle is the height of the cylinder. The area of this rectangle is the lateral surface area of the cylinder. The sum of the lateral surface area and the combined area of the two circular bases is the surface area of a cylinder. So, lateral surface area formula for a cylinder, big L, lateral surface area, is equal to C, okay, which is the circumference of the base, and the height, big H, of the cylinder, okay? So circumference is 2 pi r, which means big L is equal to 2 pi r times big H, which is the height of the cylinder. And then the surface area of a cylinder, the same formula that we were using before, same skeleton formula, where big S, surface area, is equal to big L plus 2 times the area of the base. So here is our lateral surface area formula, and then the area of the base, big B, is going to be equal to 2 pi r, or excuse me, the area of just the base, big B, is pi r squared, because that is how we find the area of a circle, pi r squared, and then we multiply that by 2 so that we stick with this formula, okay? Example number 2, find the surface area of the cylinder. Here is our starting cylinder. Here is what the net looks like, okay? So if you want to get familiar and get comfortable with drawing out the nets, that's what that looks like right there. So find the surface area. S is equal to big L plus 2 times big B. L, we're going to figure that out first. 2 pi r big H, all right? So what do we know? We know that the radius is 3, and we know that the height is 9. So big L is equal to 2 times 3.14 times the radius, 3, times the height, which is 9, okay? And I'm just going to plug that into my calculator. 2 times 3.14 times 3 times 9 gives me 169 and 56 hundredths, okay? Now I'm going to figure out big B, okay, the area of my base, pi r squared, 3.14 times the radius, 3 squared, so that's 3.14 times 9 is 28 and 26 hundredths. Now plug all of that into my big S formula, big L plus 2 times big B. So that is 169.56 plus 2 times 28.26. Just plugging that into my calculator. And that gives me 226.08. We are going to round to the nearest tenth. So that is 226 and 1/10 inches squared, because we were talking about lateral surface area. All right, skill check number 2, find the surface. Okay, skill check number 2. Number 1, okay, find the surface area of the following cylinders, round to the nearest whole number. Number 1, R is equal to 4 meters, big H height is equal to 10 meters, okay? So again, big S is equal to big L, lateral surface area, plus 2 times the area of the base. So let's start working through that. L in this case, all right? Big L, when we're talking about circular cylinders, is 2 pi r times the big H, and B is going to be equal to pi r squared, area of a circle, okay? So let's start plugging things in. To find the lateral surface area, 2 times 3.14 times the radius, 4 times 10. Plug that into your calculator. 2 times 3.14 times 4 times 10, 251.2. Big B, pi r squared, so 3.14 times the radius squared, so 3.14 times 16, 50.24. Big S equal to 251.2 plus 2 times big B, 50.24, gives me 351 and 6800ths. I'm going to follow the instructions that say round to the nearest whole number. So 352 meters squared. Let's do number 3. D is equal to 6 feet. H is equal to, is equal to 6 feet. All right, so D is equal to 6 feet. Catch that. Radius is equal to 3 feet. All right, lateral surface area, 2 pi r h, 2 times 3.14 times the radius, 3, times the height, 6, 2 times 3.14 times 3 times 6, 113 and 400ths. Big B, pi r squared, 3.14 times the radius, 3 squared, 314. Sorry, not 314. 3.14 times 9 gives me 28 and 2600ths. Big S is equal to 113.04 lateral surface area plus 2 times area of the base, 2 times 28.26. Sorry about that messiness right there. That gives me 169 and 5600ths, which rounded to the nearest whole number is 170, and let me check my units, feet squared. Challenge yourself to work through number 2 and number 4 for practice. When you do that, you should get 1,098 inches squared for number 2, and for number 4, 432 centimeters squared. Thank you for hanging in with me on this lesson. I know it was a long one.